The statement cos of pi by 3 equals a half can be written as pi by 3 is the inverse cosine of a half, where the inverse cosine represents the inverse cosine function, or cos minus 1 represents that. The graph of y equals f of x is 4 divided by pi inverse cosine negative x over 2 for x between negative 2 and 2 is shown below. Explain why an inverse for this function exists. And quite simply, that is because we can see that this is a 1-to-1 function. Determine the defining rule for the inverse function. So, we're going to let y be equal to 4 over pi inverse cosine negative x on 2, and then interchange x and y. So x is going to be 4 over pi inverse cosine negative y on 2. And now we want to make y the subject. So we have pi x over 4 is equal to the inverse cosine of negative y on 2. Take the cosine of both sides, cos pi x on 4 would be equal to negative y on 2. So y on 2 would be negative cos pi x on 4, and then y would be equal to negative 2 cos pi x on 4, meaning that the inverse function would be negative 2 cos pi x on 4. We want to sketch the graph of the inverse function on the axes on page 12, which is here. Remember that a function and its inverse will be reflections of each other in the line y equals x. So if we reflect this point here, that would reflect to there. The intercept here would reflect to here, and where this leaves the graph up here, that would reflect to here. And then we've just got to try and get the shape so it looks like a reflection. So something like that. Might want to try and look at some of these other points as well and try and get those to be well reflected, but other than that, it probably is good enough for the marks. So the next bit here is just about a spare grid at the back, just in case you mess that one up. It's always best to draw your diagrams in pencil rather than pen, because if you do mess them up, then you can't really undo it. So if y is 4 over pi inverse cosine negative x over 2, using implicit differentiation, show that dy dx is 4 over pi times the square root of 4 minus x squared. So we don't really know how to differentiate the inverse cosine, or maybe you do, but it's easier to differentiate cosine. So let's rearrange this a bit. And we've got pi y over 4 is equal to the inverse cosine of negative x on 2, which means negative x on 2 is the cosine of pi y by 4. And then differentiate with respect to x. So negative x over 2, well, that's just going to be negative a half. Cosine differentiates to negative sine. The argument won't change, but remember that we're differentiating with respect to x. So by the chain rule, we need to multiply there by pi by 4 dy dx. So that gives me that pi by 4 dy dx would be equal to negative 1 over, let's just pop that negative in front there. In actual fact, let's lose these negatives. That will be better. So that's going to be 1 over 2 sine pi y divided by 4. And then dy dx would be equal to 4 over 2 pi sine pi y divided by 4. Now let's go back a couple of steps up to here. So cos squared pi y divided by 4 would be equal to x squared on 4. So that's 1 minus sine squared pi y by 4 is x squared over 4, giving me sine squared pi y on 4 is 1 take away x squared on 4, or if you like 4 take away x squared on 4, and therefore sine of pi y by 4 would be equal to the square root of 4 minus x squared on 2. So this is going to be 4 over 2 pi square root 4 minus x squared on 2, and those 2's will cancel, and we'll end up with 4 over pi root 4 minus x squared as required. The graph of y equals 1 over the square root of 4 minus x squared is shown below for values of x between 0 and 2. And there's quite a lot here for 3 marks, as we'll see. The shaded region is bounded by the curve y equals 1 over root 4 minus x squared, the line y equals 1 and the x-axis. Determine the exact area of the shaded region. Well, the first thing to note is from the last part, we had that when we differentiated 4 over pi inverse cosine of negative x on 2, we got 4 over pi root 4 minus x squared. That means that when we integrate 1 over the square root of 4 minus x squared, we're going to get the inverse cosine of negative x over 2 plus some constant. Now, note there that all we don't have is the 4 over pi, and that's why that works. So just file that one away for a moment. We really want this point of intersection just here. So that's where 1 is equal to 1 over the square root of 4 minus x squared, which means the square root of 4 minus x squared is equal to 1. That must mean x squared is 3 because root of 1 is 1, and therefore x is root 3. So this one is going to be at root 3 just there. And then the area that we want is going to be the area of the rectangle. Take away the area underneath the curve, and so we are going to have the integral from 0 to root 3 of 1 take away 1 over the square root of 4 minus x squared dx. And we know how to do all of that. So that is going to be x take away the inverse cosine of negative x on 2 to be evaluated from 0 to root 3, which is going to be root 3 take away the inverse cosine of negative root 3 on 2 take away 0, take away the inverse cosine of 0. So that's root 3. Now think about ASTC. It's going to be this angle here that gives us, or it's going to be that angle there that's given to us by that one. And so that is going to be a take away 5 pi by 6. And then over here, it is up here when the angle is pi by 2 that the cosine is 0. So we're going to have plus pi by 2 essentially, or 3 pi by 6. And then simplifying that, root 3 take away 2 pi by 6, which is root 3 take away pi by 3.